Hi, Brandon.
Hi there, Marcin. I'm working on a survey between meetings, and the questions are all very long. So I work on a question and it says I got like 2 minutes till the next meeting. I'm like, okay, I'll go to the next question. And it's like, now you're a minute late for the meeting. I'm like, they need to make shorter questions.
Yeah. So what kind of survey is that?
One the doctor's working on, so I'm
Okay.
running through it right now.
I see.
It's one of those surveys where they say it's going to take you 20 or 30 minutes to get through, and it's more than that, but at least they set the expectations and they give you a progress bar. So
That's quite long. If it takes beyond 30 minutes.
I think it's all the thinking they have to put into it. And even then, a lot of it is about describe your team and challenges your team faces. And I'm thinking, my team doesn't face any issues. It's just me.
By the way, you retired. You don't work anymore for IBM, right?
Correct.
So how is life after retirement?
Much more relaxing. And so it's just looking at the weather and plotting what days I'm going to be outside versus inside. And then just trying to balance of, take care of some of the home projects I need to focus on more. I haven't done plenty of those, but otherwise it's a bunch of little open source projects that gobble up all the time there is.
Nice. Nice. It's nice to see that you didn't lose, uh, how to say that, enthusiasm for that, for work, still working in, as a software engineer, right? So that's cool.
I feel like I had been doing the open source for a long while, and it was that whole second job that was paying me money, but it was a whole second job in there. And I'm like, I feel like I only have time to do one of these, and one of them has my calling. So
Cool.
did you ping Vanessa out there? She says she's going to be a minute late.
Okay. Okay.
I just saw the OCI Slack lit up. So I'm like, it must have been you pinging her. Nope, her pinging us. It feels wrong putting the eyes on as the emoji reaction. I tend to use that as I saw your message. But when someone says I ran to the bathroom, it's like, I'm not looking at you. You can go to the bathroom in private. I'm just acknowledging you told me that.
Yeah, context, right? But I think people will understand unless somebody's really crazy.
I had someone at one point ask me, what the heck do the eyes mean? I'm like, it's just acknowledgement that I saw your message.
People today are a little bit more sensitive than in the past, so looks like this idea of artifact under NFD was a good idea, a great shot, because they have everything what we need, basically. Even the expression language they created, like node feature rules where you can describe everything for images. So it looks like they created everything what we need already, and we just need to start using it. Hey,
Nice.
hey Vanessa.
You're muted. Where is that
Now I'm
button
not
hiding?
muted.
There you are.
There I am. Yeah, sorry. A little late. And look, I have a different tiara today, Brandon. I'm using my closer camera so you can inspect its beauty. I did a little dance before I came on here, just like in the Big Bang Theory. Oh my God.
It was one of the more memorable episodes for me.
Yeah, it's true though. It's totally true. So
Put
what
it
did
on
I
me, put it on me, put it on me.
put it on me, put it on me, put it on me.
Okay, guys.
Sorry, Marcin, you can be blissfully ignorant of this. It's
No worries. We have plenty of times. We are just 3. No other folks are joining, I guess. So let's start with the first item. We have plan for testing with containerd and Kubernetes. So I'd like to hear what Vanessa has Harry, what is in your mind, right, about this comment you made? That you have some
Oh
ideas
gosh,
and
let me look
thoughts.
at my comment. That was like a long time ago. Let's see. Discuss. What did I say? Oh, it was just last week. Okay.
Because from a point of view, if we write some prototype under containerd, it can be instantly used under Kubernetes as well. But I mean, we cannot use it directly by Kubernetes in a sense that you provide some configuration to Kubernetes that will update containerd. I would see the path the following. You have a sysadmin that creates or installs containerd on the node, and later you join this node to Kubernetes cluster with some configuration. So I'm not so sure what you meant exactly by there.
So I wrote it down. I have it in a document somewhere. I don't have the document, but I seem to remember that the avenue that I wanted to pursue is basically doing it through the scheduler. I think there's a way for the scheduler to pass. It's probably like something simple like annotations or labels that'll eventually go to the kubelet, and then the kubelet is basically what is going to talk, interact with containerd to actually pull the container. And while I don't think that might be like the final implementation, I think it would allow us to test.
So we would have to basically extend container runtime interface with some additional method or extend the existing methods for that.
I think we could I think the first step that I would do is get it to the kubelet in the scheduler, and then yeah, see what, I think we would have to actually edit then the container runtime interface to do something with it. And I think those are like the minimal steps. And I didn't look at the container runtime interface, although actually this weekend was the first time I looked at actually containerd itself, because I was looking at a proxy plugin, actually the SOCI snapshotter. And that was super cool. So I wouldn't mind looking at the container runtime interface too, to work on this. I would start with the scheduler piece, get the metadata there, and then figure out what to do with it.
my impression of the Kubernetes scheduler is that it doesn't talk to registries.
No,
Right.
so the Kubernetes scheduler itself doesn't, but I guess the question is where would we want the registry interact? So we'd want the scheduler to basically actually, let's step back for a second. Are we dealing on the level yet with artifacts, or are we just dealing with this extra metadata that's added to like platform? My impression was that, sorry, not metadata to platform. What did you, prefers? Is that what you called it? Yeah,
Adding a
so
new field
just
into the
prefers.
platform. Yeah, it was prefers, but I could have called it anything.
Yeah, so we
but
would need to get
that's
that.
pushed into the image that's up on the registry.
Yep, and it's the registry that is going to be interacted with from the kubelet with the container runtime interface, right? So I think probably to test, what we'd want to do is make a custom Kubernetes scheduler plugin that actually does interact with it. I mean, I'm not saying that would not be the final implementation, because you're not going to have the scheduler that's interacting with like the container registry every time. But my 2 cents is still that right now we need to prove that this is useful and that it has feet, and a kind of prototype implementation that just gets that done is kind of what I'm going for. And then once you have that prototype, then you bring it to like, the SIG scheduling group or whatever. And you're like, okay, this is the idea of what we want. What's the right way to do this?
I'm thinking here, if we really need to, from the scheduler point of view, reach registry or something like that, because you put you put over this prefer field, you put some additional metadata, but all of these weights that are configurable are from the containerd side. So you don't need to really reach the registry, right? So scheduler wouldn't have to get the registry, like, I don't know, this manifests with this preferences. You need to somehow pass.
But how would it know if it doesn't do that? How would it know the nodes to select in the first place?
Yeah, you would have to provide the other side configuration, the weights on the containerd side instead of the registry itself. That's
But that's once it's already on a node, right?
So
yeah.
let me back up real quick. Today, if I was to schedule an image that was a multi-platform image in my Kubernetes cluster, how does the scheduler know which nodes to pick based on the platforms that are in the multi-platform image?
My impression is that, yeah, my impression is that it doesn't, and it would get to the node and then it would pull, and then the node would hopefully choose the right platform.
Yeah, assuming that it can find its own platform in the list, it might not, and it might just fail.
Yeah, and if it doesn't, then it's just gonna like
scheduler
throw up on you.
To my knowledge, scheduler doesn't care about that at all. It's a matter if containerd can start a container or not with appropriate message, with like it fails over the CRI status or not. So it's a matter of like containerd decides which image it should pull, and it doesn't, the scheduler doesn't need to know the details about the platform fields or whatever. So, well, I would suggest that first what we do is prototype something under containerd, and later think how to pass the informations around from Kubernetes to containerd, because I think if you want to do it dynamically to provide these preferences to nodes, we don't have a better choice than over CRI. I thought about some jobs to update, Kubernetes jobs or Kubernetes daemon set to update some stuff in there, like containerd configuration, but it's very risky. Because if you have some invalid configuration and it will not restart the containerd, then basically you lose control over the node.
Yeah, I guess the way I've been thinking about it is that the first step, so the scheduler in a way is acting as a pre-filter, because the scheduler can tweak something about the image that tells it more specific, either something about the image, like actually choose the specific digest, or it can, select a specific subset of nodes for it to go to. So we can't just totally throw that out and only rely on containerd on the kubelet. We have to consider that. So that's one piece. And then the second piece, you're right, is that I think we have to consider the container runtime interface. But that has to work with that filter, that there actually is a pre-filter extension endpoint, but I'm using it more generally to call it a filtration process.
So I would stop short of saying you can't do it without checking the machine, because we do it today already. It's not a great solution, but it's the existing solution we already have right now, which is that the scheduler doesn't know, doesn't care. It throws it to this node, and if the node can work with it, it does. And anything of picking which node is kind of thrown back as an issue for the user, that they can.
Yeah, but like, what's the point of the compatible? Like, what is our compatible? Like, what is the point of the compatibility metadata then? So you're suggesting, if you were making an experiment, is that you would have a bunch of containers that actually all work on the node, but one of them maybe would work better. But that's not really compatibility, that's the optimization thing. And we're interested in the compatibility thing. Like this container is not going to run on this node. Like the use case that I have in my mind that I still want to do, I've done early experiments for this, but I want to do more solid experiments with our established thing, is with MPI or, something of that nature. And I want it to be absolutely the case that not everyone works. It's not, because if it's the case that they all work to varying degrees, that's not compatibility anymore.
So I would say it's both. I think we want both the scheduler to pick the best node for this to run on. That's a good thing to have. It's not something we have today, but it's a good thing to have. But we also want to say that you can make your image that works on both versions of MPI. You can build both images, put them together in an index. And then if someone's running this on their own local machine for development, it just works for them regardless of which version of MPI they have installed locally.
And yeah, additionally to that, because what I think when I think about this problem, it's like if you have a bunch of nodes, it's responsibility of user admin to report what kind of capabilities exist on that host. Like, for example, if node is capable of providing GPU and other devices, right? So based on that, later
It
you
shouldn't
provide.
be though. That my 2 cents is that that information should live in the scheduler, and then the job should say like, I need a GPU, I need these other things. And the schedule, like we already have, so I can't speak for Kubernetes, but with Flux, we can already do that. We have everything that the nodes have in a resource graph. And that means that when you schedule to a node and you say like, this is what I need, you can sub-select based on that resource graph.
So in Kubernetes, basically you deal with scheduler over labels and other node selectors, right? So node feature discovery, for instance, today is reporting what you have on the node, and the way how you interact with scheduler is just putting appropriate labels. So my point is here that instead of working in Kubernetes directly on scheduler, probably there should be some mechanism that maybe extension of node feature discovery that will report what kind of capabilities, compatibility capabilities are on the node exists, and you interact with them over the labels. Basically what we are doing with the artifact right now under the project.
Yeah, I thought that's what NFD already did. It exposes that API that tells you what the nodes have. I haven't used it a ton though. That's just a superficial understanding.
Yeah, so if they can tell you what the nodes have, then the trick is to align that with what the image needs.
Yeah, so for that, I would just basically try to prototype something under containerd with this prefer, with the weights, provide some configuration that is acceptable, and then see how we could work with that. Maybe that would be a daemon that reports those preferences from node feature discovery, and you can interact somehow with scheduler over the labels that are reported by NFD project.
Okay, so just to step back, you're saying that use NFD to get metadata about the nodes. That's
Yeah.
reasonable.
Yeah.
And this is happening in the scheduler. Correct?
No, it's not
No.
happening in the scheduler. It's just reporting whatever it has, reports to the node object, and scheduler doesn't know anything about.
So the job has already been scheduled to a node. And then when you're on the node, you ask NFD what the node has. Why do we have to ask NFD what the node has if we're already on the node?
You don't ask directly NFD. NFD daemon works on particular nodes, and Kubernetes nodes objects that are stored in etcd, they receive all the labels, capabilities of the node. And later, if you want to schedule appropriate Kubernetes nodes, you are just using labels, because the labels are the mechanism to, somehow, use. Sorry, I'm missing the word. I'm saying that labels are mechanisms for selecting nodes for images.
Okay, can you walk me through the process from submitting my pod through the pod running? Because I'm not following what's happening with the scheduler versus the node versus when NFD is coming in, because it doesn't seem super useful to use NFD once you already have a node.
Because if you have a pure Kubernetes cluster, let's say with 4 nodes, right? You don't have any workload in there running yet. Let's
Okay.
say for that right now. First, what you do, you deploy. Before you deploy anything, you have 4 node objects that are corresponding to physical nodes. And if you look at the nodes label, it's empty. After you deploy the node feature discovery project, you have 4 NFD workers that are running on the particular nodes. They check
Okay, so
basically.
how they're running as daemons on the nodes.
Yes.
Okay.
And then they are discovering what kind of features the node provides. If there is GPU.
Is that like a gRPC API that's on the node? How does that work?
Yeah, there is, to my knowledge, the workers are basically sending requests to the NFD master. NFD master later labels the nodes. So after you run all of these workers, all the nodes starting to have labels. Okay, I'm capable
Okay.
of this
So NFD
GPU.
adds labels to the nodes.
Yes. And
Okay.
once
And those are
you
like those labels that are under that monster list that we were
yes.
looking at. Okay.
Yes, exactly. So after that, when you are building the pod spec, you can use the labels you want to appropriately schedule your containers to nodes you like. So for example, if you have on node B GPU NVIDIA and you want to use this GPU, you would put in the pod spec node selector GPU NVIDIA. And that's how you
So
are.
that would be done manually by the user.
Yes, that will be
So
manually done by the
why
user.
could we not do that with compatibility metadata in the scheduler that also sees that node metadata?
Yeah,
Like it defeats the purpose to have it manually done by like me, because that's how I do it now already without compatibility metadata.
Yeah, that's what I'm describing the current status. And right now under node feature discovery, I sent this proposal, right, how we could use this artifact with NFD and so on. So the idea would be that you write a kubectl plugin that basically allows you to deploy the pod, but you don't have to do all of this labeling manually from the pod side. Like if the pod spec would be automatically generated based on the artifact you have in the registry, or instead,
so the artifact from the registry needs to get to the pod spec before it gets scheduled.
or it can be a mutation webhook that if you execute kubectl deploy.
Yeah, but that's still before it gets scheduled.
Before it gets scheduled, yes.
Okay,
But
that's the delineation line I needed to understand, because everything up to this point I thought you were saying it's after it hits the node, and I was like, that doesn't make any sense.
No. It's before the schedule. So once you have that, either it's a mutation webhook that modifies your pod after deployment before scheduling, or you are doing this like some tool generates the whole spec for you.
Yeah, so basically the plugin that has the webhook or not, it would need a mutating webhook if it's changing things. That is what is going to get the metadata from the registry.
Yes.
Okay,
yes.
That is exactly what I had in mind, and I guess I didn't describe it well. That is exactly what I was suggesting that we do.
But this cannot be part of the scheduler itself. Like if we are talking about the core scheduler, it's not a part of scheduler. It's just a separate entity like mutation webhook or whatever that can reach the registry. Of course, you could write a plugin for the scheduler itself that does this thing, but it's risky because the scheduler then has to pull some stuff from the registry.
Oh, so you're saying don't write a custom scheduler plugin, just write something like Q, like a controller that does it?
Or
that suspends it and then tweaks it.
Yes,
adds the labels.
I would say mutation webhook.
Yeah, I guess yeah, because once it goes into the main scheduler, if it has those labels for the nodes, that's already going to work out of the box. We don't need to further change that. Okay.
Exactly.
Yeah. I actually know how to do all that. I could help with that.
So 2 things. One, to further sell what Marcin is working on and to unsell the prefers field that I was working on. There is no way, and it kind of hit me a bit because you were saying, Vanessa, you wanted to say this just won't schedule on this node at all. And prefers doesn't do that. Prefers just says this image and list is more preferred over the other ones, but it's always going to pick one from that list if the architecture and OS matches.
Don't we have more that we added to our proposal about what the image needs aside? Like prefers is something new, but I thought we initially had more than that.
There's, the existing stuff in the architecture just says if the OS matches and the architecture matches, the machine will try to run this something from there. And if it can't find a difference between multiple entries in there, it's just going to pick the first one. And so it's always going to pick one to try to run on the machine.
So all the examples of the more specific things we had were in the external artifact that we were designing.
Yeah.
Is that correct?
If you were to say, don't schedule this at all on the machine, that would have been different than what I was proposing. So that's one to just upsell Marcin. What's going on over there with the NFD, that's much better suited for this. The other kind of thought that goes through my head is when you talk about a kubectl plugin that looks at an artifact and then starts modifying the pod spec.
Well, it wouldn't be a
Is
kubectl plugin. It would be
you were
it
saying
would
it
be
could be
just
though.
basically like a controller. So it
Yeah.
would say like when you create objects of this type that you want to run, make sure that they make a mutating webhook. So mutating webhook means that like you can mutate things and then send them off. And that's kind of the basis of the way that queue works, is that there's a field in job called suspend, which prevents it from being scheduled. So basically it suspends everything, does a gazillion different things, and then unsuspends it when it's ready to be sent on its merry little way.
Yeah. So if it's a mutating webhook, if it's a plugin to kubectl, however it gets done there before it hits the scheduler, that part doesn't matter to me. But since you're doing at that level and you're querying for an artifact to plug in these NFD labels to modify the pod spec, does it need to be that specific? Could it be more generic that you can plug in other data and just says, hey, I want to schedule this container image to run on the cluster? And it queries an artifact that's associated with that image. And the artifact says, hey, I need all this stuff to do all these different things. Update your pod spec with all these other fields on there that make, that get to work nicely in your environment. And so they can be labels to pick which nodes. They can also be maybe security features. Maybe it says I need this volume mounted in this directory somehow. And I think there's some interesting stuff in there. I also think there's security risk if someone just says, hey, run a privileged container with all these functions that you normally would never turn on. So I'm thinking of both sides of that, but it's kind of going through my head of, does it make sense to make this more generic than just NFD?
Than just NFD? That's a good question because if you make this more generic than NFD, like if you would like to describe all of the stuff like volume mount, some security stuff, you end up having a pod spec. Like pod spec that is basically that exists today, right? We just want to enhance a little bit the compatibility aspect. So my point is, if you would do that, you are just creating another pod specification that exists today. So why would you do that? Because over
So the examples I've seen put out there is people say, hey, I just want to run a registry server on my machine. I know the name of the registry image. Let me just pull that image down. And it should know how it's supposed to run on my machine. So there are people that are looking at, how can I do this with Helm charts? Helm is just up in the registry. Just run this chart up there with the full definition. There are folks that want to start doing this more and more with Docker Compose, where they just say, hey, run this Compose thing. It's up in the registry. And it'll be interesting if this can be attached to the image. It says, hey, here's the pod spec that normally goes with this image. And it gets shipped alongside the image so you don't have to go find that wherever it's packaged separately. It's just right there with the image.
I see. If that's a good point. I mean, you would still need NFD stuff.
I make them every once in a while, not often.
But it's a very, I mean, I would at least from my point of view, what I would do, I would just push pod spec. If I would like to have a certain way of deploying my images, I would just push the pod spec as some artifact, as some custom type, and populate that to people that wants to use it, that they know exactly how to do it. But still, what we are doing here with the compatibility, still, in my opinion, this should be a separate entity because it's a
I
different
think they're
complex
different
problem.
projects.
Yeah.
So Brandon, like when your mind is going where my mind went when I learned about mutating webhooks a while back, like you can do anything with it. Like it's really powerful in that respect. And there definitely is a tendency to like, let's mutate all the things. But I think for the purposes of what we're doing here, we want to scope it very specifically to the project and just what we're working on to keep it simple. Otherwise it becomes
It's both. It could be very simple of I'm just the pod spec and pod spec is everything, but I'm just the pod spec. On the flip side, there's also the great power, and that also means you can do great bad stuff as well. And so potentially people could put in there, whenever someone tries to run this image, all of a sudden it just gets privileged access and does everything in the cluster and takes over the world.
Yeah,
be
so
great.
I want to step back and think about the use cases. So on the one hand, there is what we're calling prefers. So that's platform and architecture, right? And that's
That
it.
is
And that's it.
that
I prefer
is
these combinations of things.
so prefers you can put anything in there, but if there is an entry in there that matches the platform and architecture, that machine will find an image in the list that it will run. There's no opt out at that point. It's going to pick one of them. And the prefers
Okay.
just lets it pick one that's later in the list rather than just the first one it finds. It
Okay,
gives you the
so
option that says there's a better one than that first one.
and it's matching fields in where is it allowed to look for fields?
So the prefers gets fields from the configuration. So you would update the container D with a configuration in the container D that says on this machine, if you see these prefers, that means that it's got this image has been optimized for this GPU.
But is there anything
Pick that
in the
one.
manifest? Like in the manifest list. So let me
So-
tell you what I want and
Yes.
what I don't think is currently met. So NFD is going to have a very specific set of stuff specific to the node. And that works if I want to ask for something specific to node, but often I want to ask for something specific about the software and containers, which is related to the node, but is a slightly different thing. And so I may want to say, like, I want this variant of MPI that's in a particular container, that I have in this manifest list. How do I
Yes,
get
but.
that? Yes, but.
This is the yes, but answer. Yes, you can say this image was optimized for MPI 5.1 or whatever it is. And then the runtime looks at it and says, oh, I've got that one. Let me pick that one. If the runtime says it's got MPI 7.1 and it looks on there and it says, well, I don't have the 5.1, so that doesn't get any extra preferred treatment, it's still going to pick
But
that
I don't
image.
want it even to get to the runtime. I want my little operator or my controller to be able to, it's going to parse that, that prefers information already. And it's going to like see potentially all the images that are there. It's going to it can potentially, because we're writing this code, we can do whatever we want. Find the MPI variant that, in the original pod spec, the user said they wanted, and maybe that's just like a label or annotation, whatever. Then it gets the digest and it pins the digest. So actually there's no more work done by anything because you're asking for an exact digest. But that's happening on our controller level.
Yeah, this is where you're trying to do it on the scheduler, where everything I'm trying to do it on is in the
Well, it's
container
not
engine.
technically, if we're creating a controller that happens before the scheduler, it's not actually happening on the scheduler. So
the higher level,
it's like it's like a lower below that, which I think is actually, I really like that Marcin had that idea because I think it's a better idea than having the actual scheduler do it.
Yeah, so the higher level container orchestration platform that's going across multiple machines. It's happening at that higher orchestration level where I've been looking at this.
It's just happening, technically speaking, in a pod that is running as a controller service in the cluster. It may just be for me as a user. It may not be for anyone else. There's no layer across the cluster that it has to be running at. It's in a specific namespace owned by a specific user.
The flip side of it being run by some kind of orchestration manager above the node is that assumes that it knows the configuration settings of every node in the cluster. And so when a container D spins up and the container D has a setting in it, it needs to somehow communicate that up centrally. Same if it's going to be a podman node or some other cryo node kind of stuff. If they configure it differently, every node that has some kind of configuration that would prefer some different setting needs to be able to communicate that up via some API back to a central node so it knows it's allowed to schedule that machine.
Yeah, but that's more a node resource preference. This is like me, Vanessa, my MPI preference that is probably related to the node, but also may have nothing to do with the node.
The solution for that I see is we should extend node feature daemons that they read container deconfiguration with the prefer or any container runtime to read what is capable of and advertise this to the nodes if you have very specific wishes, because once you start container D, you provide this configuration of capabilities provided by sysadmin, that some stuff that has not been discovered by the node feature discovery project That's the way you would get this information. However, even if you could get expected result even without dealing with Kubernetes itself. It's just a matter of building appropriately the index and providing configuration to containerd. Then you will just get always the optimized image without setting those labels, if you get my point. Because for example, you say, I want MPI version, and you have node A with MPI version. I don't know what kind of MPI versions you have there. Let's say 2.0 on node A, and on node B you have 1.1, but you have properly built index with the preferences. And then on containerd you have appropriate configuration as well. So containerd for you will match the best optimized image. So even without knowing, you
that's
can
still the
get that.
wrong level though. It's the wrong level because someone in like HPC that is using a cluster is not going to have an administrator that brings up a cluster for them that stays running. They're going to spin something up on AWS, Google Cloud, Azure, whatever. And then they, as the person, are going to say like, okay, I know I have these different variants of this image in this registry. Today, because I've deployed my cluster with InfiniBand or something, I want to use this particular MPI. All I want to have to do is deploy the controller, make sure that I use the right pod spec, and go and apply it. There's not going to be any system setup or that sort of thing on the nodes.
So in that case, I would just make the controller part of an NFD project. Another source type that you have some configuration read in there, and it's being advertised.
Oh, I
to the
see.
nodes.
So you're saying that you have a controller that okay, so let's step back. So NFD right now is running these daemon sets on the nodes. The daemon sets are using some API to send that to the NFD central controller that is adding the labels to the nodes. So you're proposing another mechanism to add labels to the nodes that come from a different source, not directly from the node.
If not directly from the node, I'm a little bit lost here, because all of stuff reported by NFD are coming from the node. So what I'm suggesting here is I send a link to this NFD sources, and maybe we could add some container runtime source or custom you see already exists there, and you provide required information in there. Because what I understand is your controller discovering all of these API versions of the nodes and reporting them to the nodes, right? Or not?
Oops, wrong button, sorry. Yeah, I guess there are examples here where like the nodes don't actually matter because we usually deploy like a cluster with nodes that are all the same. And really the selection that we want to do is the image, and we want it to be intelligently selected as opposed to us having to go and look for the digest. So we want to be able to say like, okay, for this, I want my controller to just choose the image that I built. I don't remember which one it is that has these particular features. Then that all goes through and all the nodes are the same. That's kind of a use case.
Okay, I think I understand now that you just want to the orchestrator level to choose appropriate image without specifying a custom tag for that.
Yeah, I think that's a use case for these compatibilities. Like the compatibility spec lives in the registry with the images. It describes the image and it helps me get the right image. So I, the human, don't have to do it.
Okay, now I understand. I understand the use case. I will write it down. Yeah, then I don't see any better way for that than extending CRI. If you want some particular image that is being really selected by you, if you are just want to if you want to rely on the index, like without providing specific tags, right, for the image.
Yeah, because up to this point, that's what we've been doing is we've been using really long tags and, but so my question to kind of go back when I was talking with Brandon is where do I put those features in the current designs of the specs that we have?
Think into that scenario, would you ever have a case where a multi-platform image that has a couple different variants could ever be run with different variants on different nodes in the same cluster? Because once you pick the image, you're saying this image can now only be run on a subset of these nodes in the cluster, even though it could potentially be run on more.
So multi-platform. Can you say that one more time?
Would you ever have multiple variants of your image?
Okay, so
Say
ARM and
MP,
x86.
yeah. Or
Power
two different
PC.
versions of MPI or whatever it is, maybe two different
Yep.
GPUs you support, something like that in the image.
Yep.
And you've got, would you ever have a scenario where you have both of those variants in your cluster? Or more than one of the two variants?
I don't see why not. Yeah.
Because once you pick the image and you say, as a central orchestrator, I'm now picking this digest of this image, and so I'm taking away that choice from the end machine. Now you're saying that this can only be
Well,
run on a
if that's
subset
the
of the cluster.
case, if that's the case, and you want, if you want to filter it down, for example, to a particular kind of NPI, and then there's two different architectures and you have them both on your cluster, then I don't think you would choose a specific digest. But I guess, yeah, that does introduce a problem because you couldn't choose a specific digest, but you'd still want to kind of filter it down in some way to prefer. I guess like this kind of smells like, Christian's MetaHub. Basically, he would manufacture well, actually, I helped, I should say, what is it called when you admit
disclosure.
something? Disclosure, yeah, I helped him implement it. So, basically what it does is it would create an on-the-fly manifest list based on what you needed. And so then when you, and this is actually similar to Sakura Labs's approach too, which, basically gives you the image that you want to pull when you need it. So it's acting more as, I think you'd call it a registry proxy, because it basically, yeah, it creates this fake manifest that then later is queried again. So like if I had a huge manifest list and then I had two different platforms, and I'm happy with both of those platforms, but I want to get rid of like 80% of the rest of the manifest list, I would make a new manifest list with just the ones that I want. And that URI would be the one that then I can kind of continue to send off to my scheduler. But that feels like a different use case. I mean, like it's an interesting use case. Do you know if anyone's doing that in Kubernetes?
So the scenario I'm thinking of is going back to the GPU example, because a lot of people keep bringing that up to us of saying, hey, I want to support specific GPUs. Maybe half the cluster has an NVIDIA, the other half of the cluster has AMD GPUs, or maybe different model numbers of NVIDIA. And they might have an image that supports a whole bunch of stuff. And they don't want to pick just one sub digest. They want to still let the nodes pick and choose, I would think, in that scenario.
Yeah,
so
I agree. So
I'm
that's where this controller would fail. I wasn't necessarily saying the controller would have to choose one digest, but my thinking was that it would be able to take NFD, any labels that are available, any kind of node selectors that are available, and apply them in a way so that the selection happened. Let's think about this. Okay, so
otherwise, if you do pick a digest, you just limit yourself to a subset of the nodes in the cluster. And maybe it knows it wants to do that, but that's still limiting.
Yeah, so you're assuming that you have all of this in one job. Maybe it's like an index job or something. Does this job thus work using a combination of NVIDIA and AMD GPUs? Like, are they individual units of work or something like that?
Perhaps.
Okay.
I don't have a specific example of my own, but yeah.
So isn't there some ability for NFD, or isn't there some ability to add a node selector that just says this one or that one? And that would also suggest that we need some level in our metadata to also be able to filter down to that set of images. I don't think we're covering that use case.
I mean, not set of images, because from the Kubernetes point of view, you don't care about like images. You leave it to the container D side. You're just pointing this one specific manifest. I mean, the index, right? And Kubernetes never thought of this kind of problem where you have to pick a specific image on the orchestrator level. It was always container D stuff or at the container runtime. thing to do, because I see here 3 use cases right now. The first one, the compatibility stuff, we are working under NFD right now just to check if the image, doesn't matter which one, from the index is compatible with the host. The second thing is what you are describing, Vanessa. It's just image selection, particularly on the orchestrator level, that you are pointing a specific manifest, right? And the third thing is still about this containerd prefer, because people like to have magically automate or like automatically some, the best optimized image for the node without pointing to that. So your use case, Vanessa, I don't see any better option than extending the CRI, but this gonna take it's gonna be funny, because it's gonna be, you would have to write Kubernetes enhancement proposal, which takes a lot of discussions, a lot of time. So yeah, but for sure it's interesting problem.
The kind of more general problem that I'm kind of interested in what is the answer for now is we have this ability to say there's a preference. We have an ability to put node labels on something to say like, this is what the scheduler should select. But how do we when like a request is coming in, either totally, well, I'll just give one case. How do we totally eliminate some of the options in that list that we absolutely do not want to run? So maybe there's 10, they all have their prefers, and we're like, you know what? Based on what the user has put, I only want these 3 to be considered.
So
And I would
today
need
we
to like
don't-
mutate the manifest, or I need to mutate like something in the registry, and that's not really possible. But what do you want? What do you think, Brandon?
I would say today we don't. We send a manifest down to a machine, and it might be a multi-platform list with S390 and all these other architectures that aren't at all in your cluster. And it doesn't break anything because the runtime itself or the container engine itself just pulls up the list and says, here's the one for me. I'll pick the one I know I'm supposed to use.
So you're saying the solution is just to change that, have a YAML file somewhere, a JSON file, and that populate that has information about the node, and then just have that same interaction happen. So like we don't think about it from our controller standpoint. I guess then what's the point of what can the controller do then in cases where it can't, pin a particular digest?
I would say
all it can do is add the labels for the nodes. That's all it can do. The labels for the nodes and possibly the digest, and then it sends it on its merry way, and it hopes to God that the node will be compatible.
This feels like a yes and scenario where it's not us saying that it's all got to be done on the controller at the orchestrator level, and it's not all done at the container engine level. It's kind of both have their places to play in this.
Yeah, I agree.
Marcin, I see you jumping off mute, so I hope I didn't steal your thunder there.
No, I'm just thinking about this problem because you said, Vanessa, that you just deploy the Kubernetes cluster, you don't care about the hardware and whatever, right? So I'm just thinking here, maybe this problem should be taken to the way how you deploy the cluster. Like if you have some tool that is creating nodes, initiating them, then there should be some software that is also discovering some capabilities, or like MPA version that is feeding the containerd configuration. Then you will get automatically the best optimized,
like a daemon set.
Like
I just made a daemon set this weekend.
But configuring containerd over daemon set, it's not the optimal solution in that case.
No, the daemon set was setting up containerd to use the Snowshoe snapshotter. The hardest thing at the end, and what I don't think AWS knew how to figure out, is that you have to, well, they had you stop and then restart containerd. But then the Snowshoe snapshotter didn't have the sandbox image in its cache. So you couldn't pull any images to the pod because you need that to bootstrap. So it was like a catch-22, like we need the sandbox image, but we can't get the sandbox image because we can't pull the sandbox image. So all I did was use nerdctl, and I targeted the snapshotter to Soshi, So I did have to restart it. So then like the daemon set starts again because the daemon set will restart unless you sleep infinity. But then I just pulled the container, then everything worked, and it was anyway. Yeah, it was really cool. But yeah, we could have something similar, and even if this isn't the final thing, like a daemon set that does some kind of customization, adds a plugin to containerd as a daemon set, and that would be very easy for an HPC person to install. You just apply the daemon set and you're done.
Yeah, that's basically true. Over the demo said you could do that. Okay, all solved. Great.
Okay, so like what should I do? So we talked about a lot. What do you think makes sense to prototype first?
The containerd and prefer stuff. That makes the most sense. I started as well something and I pushed some stuff, but I'm so occupied right now with this NFD stuff and node feature rules and this artifact thing. So after that, not so sure if you have time, go ahead. If you don't have time, I will take a look into that, but I don't know when. But
So
it's on
I
my
should
list.
start to look at different plugin types that containerd has and figure out where we would put prefers metadata or whatever custom metadata that we want about a node. Is that correct?
Yes, but I thought it doesn't have to be a plugin. What I did in the past, I just customized the containerd platforms. Let me open the link for you.
Just
I
change
feel like
all of containerd. I was suggesting a plugin because that seems more flexible, but oh wait, let me look at this link.
Yeah,
Chat.
yeah, I've definitely gone through some of their platform code before. This feels very
Why
much like
doesn't
the
this
yes
link
end
work?
sorry again.
because the NFD work is already the orchestrator side, right? You're kind of going down that path of what can NFD do to get those labels, and now how do you make an artifact that can use those labels? So that is the orchestration level stuff that Vanessa's looking for, and now it's just okay. Now we need to do something similar in the containerd level.
Okay. I will look. I'm not familiar with containerd platforms, but I kind of get obsessed with things easily once I discover them. So I will explore this, and I also still want to explore the different kinds of plugins because I think if we could make a plugin, it would be much easier to get people to kind of use it and try it out, as opposed to needing to add something to containerd platforms. And for either of those approaches, I'll ask the same question again. Do we basically want to figure out just how to get in more metadata, whatever it is, about the node? And then that way, when some pod with a container comes in to pull, there'll be some match and filter between that. Is that like the high level understanding?
The high level understanding for me is that from the artifact point of view, we just check if the image is compatible. So that's why we are working on the artifact. But the problem you're describing, we are looking into the containerd. I'm talking about the best optimized image for you, which you want, if that makes sense to you. That's why I think we should start with containerd platform much, because those two problems are completely separate, at least in my opinion. So if you want to have something better for your image selection, or you want to set some constraint about the specific image you want to run, I would start with containerd platforms, the new matcher that I just pointed to you. And in the past, I just added a new configuration file under etc containerd. Then was the matcher TOML file, and you could provide some stuff in.
Tom's markup language.
Yeah.
Right.
Yeah. When
Yeah.
you go through that, I think you'll see a lot of stuff in platforms is similar to what Reg Client has on its side when I made my own PR, because I looked at a lot of the platform code when I was writing my own platform stuff. So there's going to be a lot of similarities between them.
So when one more question, when you use containerd platforms, does that mean that if we wanted to use that in Kubernetes, we would need to build a custom kubelet using it?
I don't know if
Or have a
Kubernetes looks at it
daemon set
today.
that like recompiles containerd and reinstalls it?
if you want to provide additional configuration for the prefer, you would need a daemon set that updates whatever configuration you provide, like whatever mechanism you build to provide this user configuration for image selection, like how you fit the prefer. Then it could be done over daemon set, but daemon set would have to restart containerd, and on the live cluster, it's kind of tricky.
No, that's exactly what I did. I mean, like, there was nothing running on it, but.
I mean, on the
Okay,
production cluster, in my case, we would have to taint somehow the node, get it out of the cluster, taint that it's not usable, and then do some operations on that, because otherwise they would really kill us if something is, you restart
yeah, if you have
containerd and
users on it, it would be very
yeah,
challenging.
yeah.
Okay, so for my, I guess, my learning, I'm probably first gonna just spend some time reading these code bases so I understand how they fit into the ecosystem. And then I'll start thinking about what to change. And maybe we can chat more about this next week.
Yeah, sure. So we are on the same page with the use cases, right? The artifact and these completely different use cases than this containerd prefer stuff. Because here in the prefer stuff, we are talking about specific image selection. In the artifact sense, we are just checking if the image, doesn't matter which one from the index, at least to some sense, is compatible with the cluster.
Yeah, I guess for the artifact, it's not that I've given up on it, but it feels like it's so hard to just parse all the links and like the refers API and whatnot that it's not well suited for Kubernetes.
Yeah. Yes. In that sense of picking appropriate image, yes. If we are talking about if image is valid with the host with the cluster, then I would say no. Right. That's my point.
Yeah. I haven't thought more about I already did some experiments with our early kind of draft of the compatibility artifact and they worked great. But I haven't thought of like new experiments to do for that because it feels like we kind of are paused on it for a bit.
Yeah. Yeah. Exactly. Okay. So if there is anything unclear or something, then just write on Slack, and I think we can clear it out or something.
Okay, yeah, this was really fun. This is like my favorite thing to discuss, so I appreciate it.
Cool.
Okay, I'll chat with everyone next week. Go on some bike rides. Go boating, Brandon.
Oh, I will.
Have some fun. Okay.
Will do.
Bye, folks.
Okay. Bye. Thank you.
Cheers.